Okay, so hello everyone. I'm Francisco Förster, and I will present a simple notebook on how to do marshalling of observations, how to plan observations, and how to find candidates in nearby galaxies. So this notebook is divided in two parts. It's a very quick notebook. First part is to query for young supernova located in nearby galaxies. The second part is to query supernova that were detected recently. And then use a new alpha tool, that is a forecasting tool, in order to plan observations in the future. So first, of course, we will import libraries, install the ALeRCE client, initialize the client, and then we will load a catalog from this paper of nearby galaxies that have been morphologically classified, and that they have a column which is the semi-major axis of the galaxy. So we will use this in order to do the cross-match. With this information loaded, then we will get the credentials that are read-only for the database. And we will define two times. For this example, I use just March, within March of this year. And I select the search radius equal to the maximum, 2 times the maximum semi-major axis of the galaxies in degrees. Okay. And then I will do this query where this has these 3 parts. First, I load the catalog of galaxies that I open here. Then I get a sample of supernova according to the stamp classifier that have probabilities greater than 0.4 and whose the first and last detection are between these dates. And I ask probability greater than 0.4. And then I join the galaxy and these supernova tables, and I use Q3C index to look for objects that are within 2 semi-major axes of the galaxy. Okay, so with this query, it takes about 10 seconds. I get a small number of objects, and in this line, I can open them in the ALeRCE Explorer. So this is a nice feature of the ALeRCE Explorer. You can open a list of candidates. So here you see the first candidate, clear type 2 supernova, in a beautiful, nice nearby galaxy. Next candidate, same thing, a nearby galaxy. This is type 2 again. Next candidate, it's beautiful type 1b, 2b in this nearby galaxy as well. And next candidate, another nearby galaxy. And next candidate, I don't see the galaxy, but if I zoom out a little bit, I see it here. So this works. I just use this catalog and cross-match with against the stamp classifier of ALeRCE. So that's the first part. Second part is we're going to use the forecasting tool, and this is under development. And I wanted to show this because this is an example of how quickly we can implement tools. So this was born after discussions with Alex Kim, Darkening Science Collaboration, and he asked us to develop this forecasting tool for exactly this problem. And in a few weeks, we have it running. It's not perfect, but this will continue in a kind of agile methodology, improving. So in here, we do we query object table and probability table, and in this case, we use the light curve classifier, and we ask for the object to be in any of these classes, supernova classes, with a probability greater than 0.4. And in this case, we will ask for a time between 70 to 40 days back in time. And I'm doing this on purpose because I want the forecasting tool to do a good job. So in the future, of course, with better methods, this will work even at early times. After I do this, I get a small sample of 20 supernova. I close the connection, and let's open this sample in the Explorer again. So I use the keyboard to move between candidates, and you can see they're all supernova, very nice candidates. And we will use a forecasting tool to see how we could observe which one of those we could observe from a given location at a given time. So here we use the forecasting API. This is the address, and this is how you use it. And we write a little function to plot the results, and we select a given observation date. Let's say 21st of April. So now we test this forecasting tool. And again, this warning, this is early development. This is not perfect. And in fact, this is using a single iteration for the model when converging, because it's fit to every object with at least detections in CDF. So these are the results. So this is a good example. This is failing, another relatively good. And you can see that some cases it does a good job. And this is the date where we want to predict the magnitude of the score now. So here you can see, again, here it did a bad job, but in general, it tends to work well. Yeah, and so I want to show is this idea of using the forecasting tool, and I'm sure other brokers are thinking of the same, but I think this is going to be more and more used. And then we select a site, let's say Magellan Telescope in Las Campanas. We coordinates, and we get the sunset and rise, the altitude evolution, etc. And we want to plot the air mass evolution of all the objects that are going to be above 20.5 magnitudes and at an altitude greater than 30 degrees from the horizon. And so we write this little function. And finally, we get this. For the given night that we ask, as a function of time, the air mass, and I can see the magnitude of all the candidates that are above the threshold I imposed. And then I get a list of those candidates that are in this plot, and then I get a nice, useful link. If you're an astronomer and are tired in the telescope, then you have this open during the night, and you just move between the candidates with the keyword. So very simple, but I think could be useful example. So that's it.
Thank you. So we have time for some question. I don't see question. I see a comment in Slack. The very useful planner notebook. Thank you. Okay, there is a question as well. How do you deal with unhomogeneous cadence?
With inhomogeneous cadence?
Yeah, from Julia.
Yeah. So you mean for the classifier or?
Oh, sorry. Yes, I want to specify for the forecasting tool.
Ah, okay. Yes. So in this case, you set the time where you want to do the forecast. So when you select an object ID, and you select you give a vector of times. So in those times you will get the forecasting. So you define when to forecast.
But you do a resampling of the curve before doing the forecasting, or?
No, because okay, something I didn't say is that we use a model, a parametric model for the forecasting.
Okay, thanks. Got it.
Thank you very much. And we will explain this tomorrow in the extragalactic session.
Mm-hmm.
But this is a modification of the Villar et al. Parametric model.
Okay, cool.
That's why we can extrapolate more safely, let's say. Yeah,
Thank you. There is one more question, and I think we still have a minute. How good is forecasting in the rising part of the light curve?
Yeah, so for the moment, I will not use it for the rising part of the light curve. And we have many students working on different methods to do the forecasting. And some using deep learning, some using parametric models. But extrapolation, as you all know, is difficult. So use this with caution, but I'm sure this will be very common in a few years. And many people will be doing this.
Thank you. Okay, let's move. We will continue now with Ian Tom tutorial.